This was just a list of everything that you should be working on or have done up to this point. Talking about chapter one, chapter two definitions. If you haven't gotten those to me, you want to get those to me as soon as possible. Then you talk about homework from chapter one, two, and three in my math lab. Then you have that assignment one, those four problems, and then you have that test that's floating out there for chapter one, chapter two. All right. So any questions on that? Everybody good?
Yeah, thank you for laying it out like that.
Yep, yep, not a problem, not a problem.
When is the test due?
ASAP.
Okay.
No real date on it. I will put a soft, like I think I mentioned before, I will put that soft date out there of the 31st, since that's a
Okay.
Sunday. But if you don't get it done by the 31st, remember I put that, the real date is May something, May 9th, I think. That's really where you have to have everything done. So, I would think you want to be done with all of everything up to chapter two. Well, this should have been up there, um, as soon as possible so you can be done with it and be moving on to chapter three, chapter four, because your next test will be on three and four. So, all right. So don't worry about that 8183. I'm pretty sure that was for another class. But math doesn't change, so I use these notes for different classes. But we're looking at scatter diagrams and correlation. All right. So a scatter diagram is a graph that shows the relationship between two quantitative variables measured on the same individual. And I'll show you what that means in a second, but that's what it is worded. Each individual in the data set is represented by a point. And you're going to have your explanatory variable and your response variable. And I'll show you the differences in those two in a second. Give you a chance to write. All right, and I already have these notes copied. So of course, if I scroll up too quick, let me know. All right, so the difference between the two, your explanatory variable explains the value of the response variable. I could have wrote that a little better. Let me try that. Your response variable is explained by the explanatory variable. And you'll see what I mean when we do an example. Your explanatory variable will be your x variable. Response is your y variable. Explanatory is your domain, while your response will be your range. Explanatory is your input. Range response is your output. Then you have your independent variable versus your dependent variable. And then also your horizontal axis versus your vertical axis. All right. Oh, also that last characteristic is that your explanatory variable will be the predictor and your response variable will be the predicted. So if you're trying to predict something, it's normally your response variable that you're trying to predict, and you're trying to predict that based on the information that you received prior, your observations. So you'll say, if I have this, In other words, if I have this explanatory variable, if I have this, what would the expected outcome be, which would be your response variable. All right. So here, it's just a generic representation of a scatter plot. You have your explanatory variable on the horizontal axis, response variable on your vertical axis. Then you have dots that will represent each one of your observations. So if you remember your XY plot, whenever you went to graph, this is an application of that. Notice we're only using the first quadrant. All right. So linear relations, when a line best sums up the shape of the scatter plot. So here are examples, and the first two are examples of linear relations. Notice how a line would best sum up the scatter plot. The next two are examples of non-linear relations. So just because it's not linear does not mean it does not have a relation or relationship at all. Notice that third one is an arc or like a rainbow. And then that fourth one is a wave, but there's still a pattern there. It's just not a linear pattern. Remember, for a linear pattern, a line is what best sums it up. And then that last one is considered no relation at all. All right. So, like I said, in that purple, it says non-linear does not mean no relation, just no linear relation. All right, associations. So if something or if a relation is positively associated, is when one value increases, the other increases as well. So you see right here, right here, just a generic way of representing it. See that the dots are going up. So that's why I have that red arrow there. So when your explanatory or your X value increases, so does your Y value. So it's considered positively associated or positive association. Negative association is when one value increases, the other decreases. So as X increase, Y decrease. In other words, it goes down. So that would be your negative association. All right. All right, your linear correlation coefficient. It's a measure of strength and direction of the linear relation between two variables, two quantitative variables. I must have been tired when I started writing this. So we can write or represent the linear correlation coefficient in two different ways. The one we will normally use is R, which is a sample correlation coefficient, but the population correlation coefficient is Greek letter rho. It's almost like a P. Look more like anybody watch baseball, the Philadelphia Phillies. P, kind of, sort of. But that's Greek letter rho. All right. So, just like I mentioned before, when it came to standard deviation and variation, not variation, standard deviation and variance, you want to find a calculator website or app that will calculate the correlation coefficient or the regression line. You can use easycalculation.com to find that as well. Or you can use StatCrunch in my math lab or whatever you decide to use. There are a bunch of free things out there that will find these things for you, but you need to be able to use it to find the correlation coefficient, which is out of 4.1, and then your regression line, which is out of 4.2. We haven't gotten to 4.2 yet, but I'm just letting you know that you will need to find something that will calculate it for 4.2 as well. All right. Any problems?
Not so far.
All right. So looking at properties of the correlation coefficient, it's between -1 and +1, inclusive. So that means it can equal to -1, it can equal to +1. If it is equal to +1, then a perfect positive linear relation exists. But if it's equal to -1, then a perfect negative linear relation exists. All right. Give you a chance to write, of course. All right, the closer R is to +1, the stronger the evidence of a positive association. The closer R is to -1, the stronger the evidence of a negative association. If R is close to 0, then little or no evidence exists of a linear relation. Once again, R close to 0 does not imply no relation, just no linear relation. We mentioned that before when we were looking at our definition of what it meant to be a linear relation. All right, number 7, it is a unitless measure of association.
Go back up to 5 for a little bit.
To number 5?
Yes, please.
Not a problem.
Okay.
All right. And number 8 is the last one as far as the properties are concerned. So number 7 is a unitless measure of association. And number 8 is not resistant. So that means it is affected by outliers. Remember, we mentioned that before, being affected by outliers. What, different things. Remember, our mean is affected by outliers. So, and your mean is actually used in the calculation of your correlation coefficient. So that's why that's affected by outliers as well. All right. So generically, just showing you how a scatter diagram would look if you had R being equal to 1. Remember, R equal to 1 is a perfect positive linear association. And then as you deviate from R being equal to 1, see how we go 0.9 and then 0.4. You get wider and wider, or your points would disperse more and more and go away from that perfect linear association. Then same thing happens in a negative fashion. If R is equal to -1, it's a straight line going in a decreasing form or decreasing fashion. And then -0.9 will start to deviate from that. And then looking at our arc, that will be R is close to 0. So once again, that's emphasizing there is not a linear relation, but that does not mean there is no relation at all. And the same thing happens in that last one. R will still be close to 0, but no relation at all exists. And like I said, those just generic diagrams. Of course, there will be points that would actually put those dots there. Any questions? Any questions so far?
Not right now.
All right. So testing for a linear relation. Steps for that. First, we want to determine the absolute value of the correlation coefficient. Remember, as far as that's concerned, we're going to put the data values in an app or website and get the correlation coefficient. Step 2, we're going to find the critical value from Appendix A for the given sample size. It's also, I think it's Table 3 in Appendix A. I think that's why I did it like that. Should have wrote Table 3 first. Table 3 in Appendix A. And if I'm not mistaken, I have a copy of that. I can send it to you guys, probably post it in Canvas so that you have access to it, but it's in your book as well. So if the absolute value of the correlation coefficient is greater than the critical value, a linear relation exists between the two variables. Otherwise, no linear relation exists. While you finish writing that down, let me see about that. No, I have it somewhere.
Where does the table come from?
The book in the
Okay.
okay. Yep. I thought I had it downloaded. I had to pull it off of Canvas. Make sure everybody copy that before we do an example. And I'll show you where it is in the book. All right, so table 2, appendix A. Everybody good? Scrolling up. All right. So it's to determine whether a linear relation exists between the club head speed and distance. So here's our data set, my observations. So we have the club head speed, that's in miles per hour. Distance is in yards. So, when we look at the club head speed, you're talking about how fast you swing the club. Talking about golf, how fast you swing the club. Swing it at 100 miles per hour. This person swung it at 100 miles per hour, and it sent the ball 257 yards. Then swung it at 102 miles per hour, sent the ball 264 yards, and so on. So, and hold on to this chart because we're going to use it again in 4.2, and I think in 4.3 as well, but using these data values. So we have a golfer swinging a club, and they mark the speed at 100, 102, 103, 101, and so on. And these were the yards that the ball traveled. So when you look at that first column, that's your explanatory variable. Second column will be your response variable. So in other words, the speed of the ball or the speed of the club explains how far the ball will travel, because there's a relation to how hard you hit the ball. So the speed is used to explain how far the ball travels. You're talking about response, talking about in terms of response. The distance the ball traveled is responding to how hard the ball was hit or how fast the club head was swung. All right. Anybody still copying before I go to another page?
What is the absolute value again? What is for the absolute value? Is that for the coefficient?
You said, what's the absolute value?
Why do we have to use the absolute value?
You said why?
Yeah.
Oh, well, we're about to talk about it. We're about to go through the process.
Okay.
All right, so has everybody copied the data values before we go through it? Everybody good?
Yeah, I'm good.
All right. So the first step is to find a correlation coefficient. So let's go to, there we go. So I would just go and type in easy calculation. And was it correlation coefficient? And it is the first one. Once again, you do not have to use easycalculation.com. Use whatever you like, as long as it's giving you the correct results. Your X value, like we mentioned before, is your explanatory variable. Y value is your response variable. You can add more rows. You can even take them away. So we're looking at 100, 257. All right, so type in all data values and you hit calculate, and there's our correlation coefficient. We have 0.9386, and it gives us this string of values down here. So now, no matter what you decide to use, if you're doing more than that, then to me, you're doing too much. If you're doing more than typing in values and hitting enter, then I feel like you're doing too much. But there are things out there, different calculators, where you have to store value here, store value there, pull this, do a formula. Yeah, if you're doing more than just typing in data values and hitting enter, I feel like you're doing too much. And then you already have to make sure that you type in all the values correctly, because if you mess up on one value, it'll change, everything. Let's see how sensitive it is. And see, I just changed that to 256 and it changed my number completely instead of 257. So that's why you have to, once again, don't forget you're human. So you want to limit the amount of things that you have to do to limit the amount of chances to give yourself to error. And then also make sure you go back and look over your data values. So you just saw that changing it from 257 to 256 changed my correlation coefficient completely. All right. So
on a graphing calculator, we just have to go to stat.
say again now.
On a graphing calculator, we go to stat, right?
I know you can do it through that, but it may be a little more. It depends on the type of calculator you have. So yeah, it just depends on the type of calculator. Because I've seen calculators where you do have to do more. You have to store data values in different places and then pull, go back to recall them and stuff like that. So it just depends on the calculator. So let's go back to our notes. So you see I have that data value here. This says take the absolute value of R. Well, the reason we take that absolute value of your correlation coefficient is because we want the positive representation because of the chart that we want to use. We're going to compare it to the values in the chart. All the values in the chart are positive. Don't forget your correlation coefficient can be negative. It can be negative. Remember we talked about going back here, positive association versus a negative association, so it can be negative. So we want to use the positive representation for it. And so that's all the absolute value does. When you take the absolute value of a number, it's always going to be a positive result. So we're looking at 0.939 as the number that we're going to use to compare to our critical value chart. All right, questions before we go to step 3? All right. All right, so let's go here. Let's go A is at 12. I think it's A2. All right, so here's the chart that we're looking at. And like I said, so you see the page number in your e-text is A2, A-2. So let's go back to the notes. I'm gonna go back and forth to this page and that page. So it says find the critical value from table 2 in the appendix. And like I said, that's page A2. And we look at the number of values that we have first. Hold on 1 second. All right, so here in our chart, notice we have 1, 2, 3, 4, 5, 6, 7, 8 values. So this all is one value. So you're not counting 16, you just count one observation. Because remember what happened, swung the club 100 yards and the ball landed, 100 miles per hour and the ball landed 257 yards. So all of that is one observation. So you have 8 different occurrences here. So that means n is equal to 8. So now when you go back to the chart, So right here, I can't write on the screen, but you see where n is equal to 8. You have 8 observations. The critical value is 0.707. All right. So before I go any further, is everybody okay with that? See what we're pulling from the chart. If I had 17 observations, then the critical value would be 0.482. All right. Everybody all right with the chart? All right. So now we're going to compare, looking at step 4, compare the absolute value of the correlation coefficient and the critical value. So we see what we have here down in the blue. Absolute value of R is 0.939. The critical value is 0.707. So the absolute value of R is greater than the critical value. All right. So the conclusion is, since the absolute value of R is greater than the critical value, then a linear relation exists between the club head speed and the distance. Right, questions on the process? And I'll try to send you guys a picture of the chart so it can be easier to be assessed. Hopefully the picture will come out okay. All right. But any questions? Any questions, concerns, comments? I think that's it for 4.1. Yeah, that is it. Trying to see, do I want to do 4.2 and 4.3 together? This 4.3 is real short. Okay, we can do 4.3 and 4.2 next class. All right. So before we close out today, any questions on anything that was said? Today was more so just setting the foundation for the calculations. But also don't forget, chapter 4 is only 3 sections. So that's why I'm not really, I know we got time to still do some work. That's why I'm not really pushing it, because, we'll be done with chapter 4 if I really wanted to grind. So next class, we'll look at 4.2 and 4.3, and then we'll talk about how we're going to move forward. But questions, concerns, comments, anything, anybody before we close out today?
I have one question. For the homework, do I need to send it to you in an email?
Which homework? Are you talking about the assignment?
Yeah, like when you gave us the 4 questions last week, did you want me to take a picture and send it to you in an email?
Yes, that's fine. Yes.
Okay, cool.
What about the definitions?
Definitions.
Or is that with the homework?
No, definitions, you can either take a picture, like he mentioned, or if you just typed it up, then you can just save it on your computer and then email it,
Okay.
Yep, either way is fine.
Cool.
All right.
Thank
Anything
you.
else? Not a problem. Thank you.
Thank you.
Yep, thank
Enjoy
you.
your
So
day.
you guys are good. Have a great day, and I will see you on Thursday.
Bye.
Thank you.
Have a good day.
All right. Take care, guys.
Bye.
Professor, can I ask you a question?
Sure.
Okay, so I know I emailed you about this Pearson thing because I've been trying to purchase the $75 thing for the course so I can get to my
Okay.
homework.
Hold on one second. Let me stop the recording since it's a personal, conversation.